Previously, I created geometry for debug, which will allow us to see what we're doing within the scene. We can now actually use this to test for intersections with our geometry, and in this case, you'll want to be testing for intersections with the terrain. I'm going to create a subscene to work with this. I'll go to my subscenes folder. I'll create a new subscene here. This will have the prefix sub to specify that this is a subscene, and the name will be Terrain Geo. I can enter the scene. I can then remove everything from the scene. We do not need any cameras or lights within the scene. In the HDA folder, I'll go to my terrains, and I'll add my geometry terrain to the subscene. I can then return to my test scene. Here I can delete the existing terrain object. I'll then create an empty game object. I'll add a component to this game object, and this component will be a subscene. I can now specify my subscene, and in this case the subscene will be my terrain. We should now have both our player and our terrain geometry as subscenes. So now I'm going to add a physics test. So for this test I want to add a component to my player, although this type of component should work for any kind of players that we need to apply to. So I'm going to add a folder for this, and this folder will be called characters. I'm going to create a generic component script here. This is going to start with CMP to specify that it's a component, and I'll call this character. I can then work on this script. I do not need any of the using statements. This will no longer inherit from modern behavior, and I can remove all of the default logic. This will then inherit from iComponent data. The variable stored within this component will be a bool called isGrounded. Here we're going to be using raycasting, and to do this I want to use a physics library, and in this case I'm going to use the Unity physics library. I'll get this with using unity.physics. I'm then going to store ray input, and this will be stored in the variable ray input. I will also add a raycast hit, and this will have the variable name hit. This will give me my first physics component for the characters. This is probably something which we could evaluate separately from the player, and we could probably apply this for every single character. But until I know that I actually need to do that, I'll implement this as part of the player script. I'm going to update this after I've updated my position. So after the for loop where I set my current position and my current rotation, I'll need a reference for the physics systems, and this will be the physics world singleton. And I'll give this the name physics world singleton. I'll get this using the system API library with the get singleton function, and here I'll look for the physics world singleton. Essentially this will be running our physics system for dots, and this will be the reference to our instance of the physics simulation. Next we'll have a for each loop. We're going to have an argument, and this will be specified with bar, and the argument will be grounded, and we'll get this using the system API, and we'll use a query. The component that I'm going to query for will be the CMP character, and we'll look for any entity with the tag player component. I'll want to modify values for this component, so I'll specify this as a ref read write component. So now I want to test the ground position based off the position of the character, but I don't want to actually start my test at the base of the character, as I do want to guarantee that this is going to be testing from a position which should always be above the ground. So I'm going to position the ray which I'm testing above the base of the character. So this should help prevent the character falling through the floor. To make the variable name a little bit more explicit, I'll change it to ground check. I then want to update the value of this ground check parameter. But I have made a mistake with my component. I need to make sure that all the variables are public. This also should not be a class, it should be a struct. I can then access my variables. So this will be groundcheck.write_rw.ray_input, and I'm going to update the starting point for the ray. I'll set the ray with the current position of the character, but I'm then going to add an offset to this, which will raise the position of the ray. So I'll add a new float 3, and this is going to be unit vector in y. So this will be 0, 1, 0. So this will give us the start position of our ray. We'll also want a distance which we're going to cast this to, so we want an end position for this ray. I'll specify this with groundcheck.valueReadWrite. We'll be updating the ray input struct, and we'll be updating the end value. And we can make this test by quite a distance, but for the moment I'll give this a length of -1. We'll want to be able to visualize this, and for this we'll draw a line. So I'll say debug.drawLine. I'll draw this from my ground check start position to my ground check end position. And for the moment, I'll give this a magenta color. I can then test this in Unity. We should now have a line representing the ray from our player. This should start from the center of the player and should point downwards. So this is not currently working, and that is because I have not actually updated the player. The player does not currently have any information for the ray itself. So I'm going to need to update my game object. I'm going to need to add a component. If I look at the inspector for the player in the runtime, we'll see that we do not have any of the information being used to check the ground. So I'll need to update my authoring script. I'll add this within the bakeplayer method. We'll call the add component function, and I'll add the CMP character component. Now I can test, and we should have a visualization coming down from the character, which should be magenta, and this should be pointing directly downwards from the center of the character. I do have performance issues here, and this is because of testing against the terrain output from the HDA. The HDAs are convenient, and they allow us to transfer information and update information quickly for the scene, but we do actually want to convert them before we actually create the final game itself. So for example, I could reset this asset, and then under the bake options, I can bake this as a game object. If I deactivate my HDA and then test against the game object, I'll get performance which is more in line with what I expect. Although in this case, that's actually not the main cause of the problem. I currently have a lot of comments, and I'm printing out a lot of things to the screen. If I cut down on these, I'll get better performance as well. Logging is always a very expensive operation. I now have a magenta line projecting beneath my player. I may actually want to make this a lot longer than what it is. That will depend on the speed of player movement though, as we do not want to project through too much geometry if we do not have to. So now we have a ray to test collisions. The next thing that I want to do is actually test the collision itself. I'll remove all the debug geometry that I was testing, as I'm going to use this to test the collisions, and currently it's cluttering the viewport. I can then return to the casting of my ray, and I want to test if the ray is colliding with anything. After I've drawn the line, I'll add a collision filter. I'll store this in a variable called filter. This will be set with a couple of bit masks. The first will be belongs to. This is going to be set using a bit mask. I'm going to want to set this to an integer where everything is 1. So I'll use a not, and I'll flip all the values of 0. And this should give me an unsigned integer where every bit is set to 1. This should essentially mean everything, and it will be followed by collides with. And in this case, we will also essentially set this to everything. I'll set the group index to be equal to 0. So this gives us a collision filter struct, which belongs to everything, collides with everything, and has a group index of 1. This will essentially allow us to define which geometry we're going to test with our raycast, and at the moment we're going to specify everything, although this will change later as we add more geometry. I can then use this to update our ray input, so I'll have groundcheck.valueReadWrite.rayInput.filter, and I'll set this with the filter. So now I've specified the start and the end of the ray, as well as what the ray is going to collide with. I can then use my physics world Tingleton to cast the ray, and I'll cast this with my groundcheck.input. This will be read only, so I'll specify this as value RO, and the input will be ray input. We'll need to get a value out of this function, so the second argument is an out value, and this will be stored in our raycast hit. Once again, this will be in our ground check. This will be a value read write because we write into it, and this will be the hit variable. The cast ray function has a return value, and I want to use this value. It is tempting to set this with our ground check value, and specifying that when we get a hit, the character will be grounded. This is of course not an accurate check, as the ray extends far beyond the feet of the character, so we'll not use this as our ground check. I still want to store this value though, so I'll create a variable for this. This will be a boolean, and it will be called hit. So now I've got my ray, and I'm testing if I'm colliding with geometry. And if we're not colliding with anything, we can return to the start of this loop. So I'll say if not hit, then we'll continue. If I do have a hit value, I want to test where this is happening, and I want to visualize this. So this will be btdebug. I am going to use a sphere, so use the drawSphere function. I'm going to get the position using my ground check. This information should be stored within our hit variable, and this should be stored in a value position. I'll set the radius to be 0.01, and I'll give this black color, and we should now be able to test to see where the ground has been hit. And when I test, I see nothing. In the script, I'll change the debug to be white, as black is not the most visible option. I'm then going to update my geometry. I'm going to add a rigid body component to this. This will be a standard Unity physics component, and in this case it will be a mesh collider. I'll also add a rigid body component to this. I'll then make sure that I'm turning off gravity, and I'll then test again. I'm still not seeing anything, so I'm going to assume my debug display is actually way too small. So I'm going to enlarge it. I'll change the size to 0.1. I'll test again, and I'll zoom into the feet of the character, and I am displaying it. It is still too small, so I'll enlarge it a little bit. This time I'll give it a size of 1. I can then test again, and what I want to see is that the hit is following the ground and not the character itself. When the character passes too far under the ground, the hit disappears. If I zoom in on my character now, you'll see that the hit is level with the ground. It is currently being registered just beneath the character's hips. So this is matching up with our geometry, and this will give us the point at which the character should be contacting with the ground. So this will give us our initial test for the ground. It will also give us our initial raycast system. So this is something which we'll need to do for the player, but we'll probably also want to do this for the NPCs themselves, so we may separate the system at a later stage. But for the moment we're getting the collision point with the ground, and next I want to be able to use this to update my character.